Swayam Prabha. Digital India. Educated India.
The purpose of the various project management techniques that we have been studying so far has been to develop a project plan, a plan of action, a schedule of doing the various activities in the project so that the project can be implemented. So we are now making a transition from this lecture from the phase of planning a project to the phase of project implementation. So what we are assuming is that we have a project plan which is to be implemented, and this particular project plan has to be implemented so that all the activities go as per the plan, and there are very little departures in terms of deviations from either the expected costs or the schedule slippages. So the primary purpose in project monitoring and control is to ensure that the project proceeds as per the plan that you have set out to achieve. So PERT cost is one technique which helps us to achieve this. So in this lecture we are going to be talking primarily about how PERT cost can be used effectively as a project monitoring and control tool. To give you a bit of a background, PERT cost was developed in the United States by the Department of Defense and NASA way back in 1962. Subsequently, it has been used as a kind of a tool on almost all projects that NASA has done, which means that it is now a part and parcel of implementation of all projects as far as NASA is concerned. The basic idea here is that the costs are to be measured and controlled primarily on a project basis rather than according to the functional organization of the firm. That is one of the key concepts in PERT cost. It makes a departure from conventional cost accounting systems, and it says that the departure is primarily in terms of how the costing is to be done, rather than doing the costing on the basis of the functional organization of a firm as it is done conventionally. In a conventional accounting system, what happens is that an organization says so much has gone to materials department, so much has gone to department A, so much has gone to department B, and so on, irrespective of how much work the individual departments have actually done. So the focus here has shifted to looking at costs on the basis of the project and specifically with regard to the activities of the project. So cost is allocated to the individual activities, and accounting and subsequent monitoring is done with regard to those activities. So this is the major departure that we have from conventional accounting in the PERT cost system. And the activities or groups of activities are in fact the micro cost centers. I think this is logical, because if you have to control costs, costs should be controlled at the point where they are incurred. Costs are incurred on individual activities, on individual jobs. So if you have to control the costs, the right place to control the costs is the individual activities or the jobs. So this is in fact one of the significant things which is done in the PERT cost system. Now another very logical thing that is done in the network cost accounting system is that the responsibility for expenditure should coincide with the responsibility for managing the activities that give rise to the expenditure. This is a very simple principle. If I am responsible for doing something and I have the budget for that thing, then both the responsibility for the expenditure and the responsibility for doing that job should lie with me. Unlike a situation, for instance, in typical government departments here, the sanctioning authority is located somewhere in some building, they sanction the money and immediately after sanctioning the money they forget about it till the end of the next financial year, and the money comes to somebody who has the responsibility for doing the job. So when you segregate the responsibility for doing the job and the responsibility for that sanctioning that money, then of course there is a greater likelihood that the job would not be done as per schedule, isn't it? So this is one thing here. What it is saying is that if the project manager gets a certain amount of money for performing a certain activity, he is responsible for that activity and he should be caught if he does not do that activity as per the plan. That is the kind of thing. So there is this binding of the responsibility for both the expenditure and the responsibility for managing the activities. Both of them should go together. And of course it is strange that one who sanctions the expenditure has nothing to do with the activity implementation and actual cost control. In fact, this is one reason I think for the inefficiency of most of our government and public sector departments. So keeping these basic principles in mind, the PERT cost system uses the notion of work packages to define the various stages in which the project ought to be monitored and also the manner in which it ought to be monitored. Now what is a work package? A work package is nothing but a chunk of the project, a part of the project. It could be an activity or it could be a set of activities. So a project can be divided into work packages in various ways. We had seen this when we were talking about the work breakdown structure of a job. You can divide a project into individual work packages in a variety of ways, just as you can cut a cake into a number of pieces depending upon the usage. You can cut it into 4 big pieces, one for each member of the family maybe, or you can cut it into 20 pieces and so on. So it depends. So in the same way, what would happen if we divide it into too many small activities? So a division of the project into too many small activities may facilitate detailed planning and scheduling, because you have now detailed jobs which specify exactly what has to be done. So from that point of view it is beneficial, but it is not convenient for cost control purposes. Why is it not convenient for cost control purposes? Obviously because if you have a project, let us say, which whose total cost is 1 crore and you have small activities which cost 8 annas, 1 rupee, 2 rupee, the number of activities that you will have will be phenomenal, and keeping track of all those activities would be an enormous job in itself, and therefore accounting would become very, very difficult for such things, isn't it? So it is not convenient for cost control purposes. On the other hand, a division into very large chunks of work would deprive the project of the necessary detail. For instance, if you can look at the, after all, the project itself, if you do not divide it at all, is one project. So you monitoring the project as a project you would not know, because you would not know which are the parts of the project which have to be monitored. So it deprives the project of unnecessary detail and is not conducive to effective monitoring and control. This kind of thing is not conducive to effective monitoring and control, because there are no stages, there are no parts where you can check. You would like to find out, okay, project has 15 parts, we will check each part, and at the end of 2 parts we should be able to say yes, so much, 2 parts are over or 3 parts are over. So in that sense, large chunks also are not necessary. So the conclusion really is that if you have to do effective monitoring of a project, you should be able to divide the project into manageable work projects which are neither too big nor too small. And in fact, that is the key notion in PERT cost. The recommended work package. What should be the characteristic of the recommended work package? Work package is nothing but a collection, a chunk of the project or a collection of activities in the overall network. The recommended work package should be neither too small nor too big. Okay, I mean, it should be manageable. That's what we have seen, because if it is too small, then also it is useless. If it is too big, then also it is useless. But what do we mean by too small or too big? These are relative terms and would have to be defined for each project individually. Though of course, the DOD and NASA guide, they considered too big or not too small, say about $100,000 worth and 3 months duration as appropriate. So this was the recommendation of the Department of Defense NASA guide when they proposed the work packages. They said each work package should be about so much worth in terms of money and should be about 3 months duration, and this is appropriate. But obviously these figures would depend upon the context and you can define your own figures. These are some guidelines that they had given. The second feature of a work package should be that the responsibility should be easy to identify. Preferably each work package should be or would be done by maybe one particular individual or one particular agency, right. For instance, if Engineers India Limited has one large project of setting up maybe a thermal power plant somewhere, maybe the electrical installations and the ducting they would have probably subcontracted to some agency like Larsen and Toubro. So Larsen and Toubro then becomes a subcontractor for Engineers India Limited in doing this particular project, and their job is to look after a couple of work packages pertaining to the electrical installations. So whenever you are trying to monitor the progress of those work packages, you can clearly identify the responsibility, and the project manager can immediately identify, okay, this is the responsibility of Larsen and Toubro. So if there is something wrong, he can immediately pick up the telephone, call up Larsen and Toubro immediately and get in touch with the number, say that work package number 493 is not going as per schedule immediately. So this is one other advantage of properly defined work packages, that the responsibility can be clearly identified. And the work packages should be still small enough and manageable for planning and control purposes. So these are the 3 major requirements, you can say, of a work package. So what we now conceive is that the original project network is now conceived in terms of these manageable work packages, and we develop the project network in terms of these work packages, where the work packages are regarded as the activities of that particular project. The work packages could then be a combination of the original activities, some combination or a sub network of the original network could be a work package in that sense. Let us now look at some of the assumptions in PERT cost. Well, the assumptions are, this seems to be a very limiting assumption. What it says is that it is assumed in PERT cost that the expenditure on a work package is uniform throughout its duration, which means a work package might have a duration, typically 3 months, 2 months, 6 months, as the case may be. The assumption being made is that during each month the total expenditure on a work package is constant, right. Now this could be true and this need not necessarily be true. We will talk about this assumption in a greater detail little later. So this particular assumption may be reasonable as a number of activities are included in the work package. So this is true, isn't it? So when there are a number of activities included in the work package, so if there are 8, 10 smaller activities, so some activity is finishing, the other activity is going on and something. So it is like a steady state situation. It is like trying to say, when you are talking about population control, total number of births is equal to the total number of deaths. So some number of activities are being finished, new activities are being added on. So on the overall population remains constant in a city or in an overall institution. That is the kind of thing that we are trying to say. So this might be reasonable because of this assumption. However, if this is not reasonable, the work packages could be redefined. How could they be redefined? You see, typically depending upon the pattern of expenditure, you might have a higher expenditure in the beginning, low expenditure here, and then higher expenditure towards the end of the activity, as the case may be. Then you might want to sort of break this entire activity or this work package into 3 work packages, something like this. Let us look at this problem in a little greater detail and let us try to see how the spending typically occurs in an activity, in a project, in a say if I plot the monthly expenses versus time in an activity, it is quite likely, it is generally seen, say when you have to do some activity, right? You have to do some activity, normally in the initial period you have greater expenses, and these greater expenses are probably you have to buy some materials. Suppose you want to do the painting of your house, right? So for doing the painting of the house, initially the person who is going to do the painting, your contractor will tell you buy the paint, buy this, this. So your expenditure will be pretty high in the beginning. Once you have given him all the stuff, the pattern of expenditure will come down, and typically it will be at a low level as the project, as the activity proceeds. Towards the end, when the activity is over, you got to make payments to the labor and everything else. So there is again a peak towards the end, typically. This is what happens, right? So one can expect that in a typical activity, the pattern of expenditure will show an initial peak, a common period when the activity is going on, and finally a situation when there would be a final settlement of expenditure with all the contractors. So you have all the money has to be shelled out during this particular period, and this would be the nature of the activity. Now one thing is, if there are a number of activities of this kind, then each with its own peak, quite likely that all of them added together will give you a uniform peak, and therefore the assumption that you have made in the PERT cost about uniform pattern of expenditure would remain valid. But suppose this was a very critical activity, and in this this was a single work package, and this assumption is not valid. What you can do is you can sort of conveniently break this down into 3 distinct phases in this manner, and I can then define as it were 3 activities. The first activity when the pattern of expenditure is this high, the second activity from here to here when the pattern of expenditure is low, and then the third period when the pattern of expenditure is high, and then during each of those activities I would have a uniform pattern of spending. So even if the pattern of spending is not uniform, by suitably redefining my work packages, it is generally possible to conform to this assumption of uniform pattern of spending, even when you have non-uniform patterns of spending, just as I indicated here. So with this background, let us now try to see how these concepts can be utilized for project monitoring and control, right? So for that, let us take a sample network, and let this be our sample network. This is a network which has 8 nodes as shown here. It is an activity on arc representation, and what you see here is that we have the first number in the parenthesis is the duration in months, and the second number in the parenthesis is the cost in thousands of rupees, right. So what it means is simply that activity 1-2 is an activity which will take 2 months and will cost us 40,000 rupees, and we have similar figures for each of the other activities in the project network. Now you imagine that these individual activities are nothing but work packages. That means we have already considered and maybe combined certain activities, and these are the revised work packages which have to be monitored and controlled as far as the project is concerned. Okay. So what we can do is we can very easily find out the duration of this project. How can we find out the duration? It's very simple. We can do a forward pass, right. So let us do a forward pass. For instance, this is time 0 for the project, and this is 2 months, and this is going to be 2 months again. Then coming to node 5, this is going to be 4 months. Coming to node 4, this is going to be 6 months. And coming here from all the 3 sides, the maximum is 11, so this is 11 months, and this particular value is just going to be 5 months, and this particular value is 12 months. So this is the forward pass which reveals these particular times. We can do a backward pass for this and determine the latest occurrence times for these nodes. So you can find that this is 12 months latest occurrence time. This is going to be 12 minus 5, which is 7 months. This value is going to be 12 minus 1, which is 11, which is going to be so much, and then 11 minus 5 is 6, 11 minus 3 is 8, and then for node number 2 it's going to be 8 minus 2, which is 6, and of course here you get 2, so 2 is the smaller value, you get this value here. Similarly here 11 minus 4 is 7, and 7 minus 3 is 4, so this value is going to be 4, and what you get from here is going to be simply 0. We have just worked out the earliest and the latest occurrence times, and what you can see from this particular problem is that the critical path, for instance, is going to be this one. This is the critical path in this particular project, right. So what you can immediately see from here is that this critical path we can identify the early start, latest start for all activities. We can make a table which would just, for each of the activities, this is the duration in months, the early start of the activity, the late start of the activity. Obviously when the early start is equal to the late start, it shows the activity is critical. For instance 1-2 is a critical activity, and 2-4 is a critical activity, and similarly 4-6 is a critical activity, and 6-8 is a critical activity, as we just determined. And the total cost in thousands of rupees is known to us for each of these activities, so we just write it down. Then what we do is we compute the cost per month. Cost per month is obtained by dividing the total cost by the duration, because we are now making an assumption that if this activity costs 40,000 rupees, it means in each month you are spending 20,000 rupees, and so on. So we have computed this figure of 20, 25, 15, 30, 20, 20, 10, 25, 40 and 20 for each of these activities as we go along in each of these periods, right. Now just to continue the computations, we will have to first draw a sort of a time scaled network, and we will consider the two possible extremes, the early start schedule and the late start schedule. For instance, the early start schedule for this project looks like this. You find there are 8 nodes in the network. This is a time scale network, right? So this is the first period, second period, and so on. There are 12 months in the project. This project lasts 1 year, 12 months. And what we have is, if we follow an early start schedule, then these are in fact the floats associated with tasks 2, 5 and 5, 6, right? And similarly here and similar. So this is the early start schedule. And the figures adjacent to each activity are the monthly costs which we had just computed. So what you can do is, you can now do something like a resource aggregation exercise which we had done. So when you do a resource aggregation exercise, you can find out what is the total expenditure that is being committed in each period. For instance, in the first period, as you see, these two activities 1, 2 and 1, 3 are actually active, they are going on. And the expenditure here is 20,000 rupees per month and 25,000 rupees per month. So the total expenditure here is 20 plus 25, which is 45,000 in this period. Similarly 45 in this period. In this particular period, 1, 2, 3, 4 activities are active. So 30 plus 15 plus 20 plus 20 is 85. So 85,000 rupees will have to be incurred in this particular month. And so similarly 85 here, 80 here, 80 here, 55, 30, 30, 30, and finally in the last period only 40, and only 10 is going on in this particular period, because this is the only activity which is going on. All other activities are over. From this figure of this is the monthly expenditure. This in itself is a very useful bit of information for purposes of implementation, because it tells you what are the cash requirements for implementing this particular schedule. You require so much money in individual periods and so on, and the cumulative requirements are 45, 90, and so on. So the total sum of money that is being spent on the project is 615,000 rupees, right? That means 6,15,000 rupees is being spent on the project over a period of 1 year, and the monthly spendings are shown as shown here, and this is what the early start schedule is giving us. Okay. Now you can do one more thing. You can look at the pattern of expenditure if we, instead of the early start schedule, follow a late start schedule, for instance. What would be the implications? You can see that the implications are summarized here. We draw a time scale network on a late start basis. Here all the activities are shifted as late as possible. So you have the dotted lines here prior to the activities. So most of the activities are going on towards the later period. So what you find is now, for instance, that during this particular period you have a number of costs which are sort of going on, and these costs typically are only 20 here, 20 here. Mind you, this should be a dotted line here, because this activity takes only 2 days. It's the latest possible schedule. So this is actually a dotted line, really, this one, this one. This is a late start schedule. This particular activity takes 2 periods. So there is no, I mean, these figures are okay. 20, 20, 40, 40, and then 35, and so on. So what you find is that as when you look at the late start schedule, the expenditure is shifted to the right as far as possible, though of course the total expenditure is the same, 615,000 rupees. You see, the difference is only in terms of how you incur the expenditure. It's like trying to say, suppose you have to get something done in your house. There is a man who comes, he says I'll charge 100 rupees for this. One possibility could be he could charge 100 rupees in advance, so on. That is something like the early start schedule, and the late start schedule is I will do the job and at the end of it I will charge 100 rupees. So both are charging 100 rupees, but it's the timing of the expenditure which is really different. Okay, so something similar is happening in this particular example, where you find that in the late start schedule the total expenditure is the same, but the timing of the expenditure is very different. Now the question therefore is, if we now plot this information of cumulative costs on a graph, the graph looks something like this. At every month we have two values. The upper one is the early start cost corresponding to the early start schedule, the lower one is the cost corresponding to the late start schedule. So for each of the 12 points we have these 2 points, and so what you find is that the cumulative expenditure is much higher at every point of time in an early start schedule. You see what it means is, it means simply this, that at the end of the 6 months here you have spent something like 405 kilo rupees, whereas here you have spent only something less than 200 rupees so far. So you have greater money in your pocket when you are doing a late start schedule, right? It's like trying to say, if I have a 100 rupee note and I have asked that man to do the repairs, if he charged me in advance I would have lost the 100 rupees note right away, but if I pay him at the end of the job I retain the 100 rupee note till the end of the job is over, so I will remain richer till the end of that time, and I can earn interest on that money for a longer period of time. So really speaking, the total NPV of expenditure is going to be lower when you are doing a late start schedule as compared to an early start schedule, which means that if you have to raise the capital through an equity loan, or you have to raise the capital from a loan from a bank, you will have to take a lesser loan if you follow a late start schedule as compared to an early start schedule by virtue of this particular fact, right. So the question that naturally one has to answer is, out of these two schedules which one is a better schedule to adopt for purposes of implementation? Both schedules give me guarantee that the project is done within 12 months if you follow those schedules, but which one is better? Yes, any responses to that? Somebody would like to say which one is better? Should we follow an early start schedule or should we follow a late start schedule?
It depends, sir. Because you are doing activity at the late, if it gets postponed by some one day, that will incur your cost.
No, where is the cost? I mean, you
early start gives us most of that, like on nodes.
Precisely. So as you very rightly identified, the late start schedule will give us a lower value of the NPV of expenditure. So if you want to minimize your costs totally, the late start schedule would be the ideal thing. You can't have a cost lower than the cost that you get in a late start schedule. But what happens in a late start schedule? Late start schedule, you have postponed all activities to their latest possible value, and therefore you have no slack available in case an emergency occurs or something happens. You cannot postpone any of the activities any further, and therefore if you are operating in an environment where there is no risk, where all your suppliers are very reliable, that means if you are operating in a Japanese environment where just in time system. So late start schedules are just like just in time system in the Japanese context, and what it means is that you have, in this case, suppliers will come on time, everything will happen as per time, and therefore things will go on and very good. So in that case the late start schedule is very good. But if you operate in a chaotic situation like we have in many situations in our country, in India, what happens? You have kept a margin for something, the supplier tells you, we cannot send you the material today, something has happened, there is a strike in the factory, it will be delayed by 2 days or something. Now if you are following a late start schedule, it would mean that your project would slip by 2 days. But if some of these activities had floats which you have not utilized, you could absorb some of this uncertainty through the slack. So really speaking, an early start schedule gives you a lot of buffer, gives you a buffer to act against uncertainties, and you can utilize this buffer. What you can say is the additional cost in the early start schedule is only because you are providing this additional buffer to guard against uncertainties. It is very much like, you take the example from inventories. Just in time manufacturing says do not keep any inventories. So you do not keep any inventories, and it is okay as long as everything is reliable. But suppose there is a demand or something, there is a fluctuation in demand and you are not able to satisfy that demand. So what do? You typically keep inventories. So inventories are useful in situations where you have uncertainties. Similarly, the early start schedule is useful in situations where you have these kinds of uncertainties and you want to guard against those uncertainties. So really speaking, you can, if you are a perfect just in time type of environment, use the late start schedule. If you have a lot of risks and other things, use the early start schedule. If you are somewhere in between, then you can choose one of the many possible schedules in between this region. This region in between is the region of feasible schedules. How? Because instead of shifting a job entirely by its total float, you can shift it by only 1 day or 2 days, 1 month or 2 months. You can have some intermediate schedule, and that intermediate schedule will be between this. So you can have a compromise between an early start schedule and a late start schedule depending upon the context. So what really happens is that based on considerations like these, you can select either an early start schedule or a late start schedule or any schedule in between for purposes of implementation. And the schedule that you have chosen would obviously lie between these two limits in terms of the total expenditure. So now let us assume that we have chosen a schedule. The schedule is chosen and we now go ahead with the process of monitoring and we want to implement this process. So how do we go ahead? Project monitoring basically means we are concerned about three things. We are concerned about the performance of the project, that things or activities are being done as per specifications, they are being done at the appropriate times, and we are doing them within the cost. Now how do we take care of this? For the three indicators of project progress, that is the performance, the time and the cost, there has to be a common reference for purposes of measurement and comparison. The important thing is a common reference, and this common reference is nothing but the original plan or the budgeted cost and value curve which we just determined. So what we just determined in form of the budgeted cost and value curve, that is either an early start schedule or a late start schedule or any schedule in between, that serves as a common reference, and this is used for finding out how the project is performing as you keep going on. So that's the important yardstick. Now how exactly do we do the monitoring? How exactly do we go about monitoring the whole thing? Let's look at that. Basically we look at three curves. The first curve, which we denote by capital A, is the budgeted cost schedule, and that is shown by a solid line here, and this is that portion of the line which we just constructed for an early start schedule or a late start schedule or whatever it might be. So we have the budgeted cost schedule. So this is the budgeted cost schedule curve, and A, small a, is any point on the curve capital A. That's the notation that I am using. So this is point A. So if this is time now, what it says is that the budgeted cost of the work completed by this particular time should be A. That's what it is saying, this small a. However, the actual cost incurred till date is this dotted line. So if you keep on plotting the dotted line, probably the actual cost would be something like B. and obviously B minus A is not the increase in cost. Why is it not the increase in? This is the budgeted cost and value curve. We should have done work up to value A and spent money equal to A, but we have spent money B, which is higher than this. But it all depends upon what you have done with that money. So we have the third curve here, this particular curve, which is the value of work completed till date. So what we find is that today we assess the situation on the project and find out that only C worth of work is done. So really speaking, the overrun in cost is C worth of work is done and we have spent B. So the total overrun in cost is B minus C, and this is the value of the work done. B minus C by C is in fact giving you a value of the cost overrun for the project. So this is the formula that you will use for determining the cost overruns, right? B minus C by C, and if this value is negative, it shows that there is an underrun. That means you are lower than the cost. Similarly, let's try to see how you will measure the time overrun in a project. Again, for a time overrun, what really happens is the time overrun is nothing but the horizontal distance between curve C and A. This is C and this is A. How? This is time today. Today I have done this much value of work. If I project this horizontal line, this intersect this budgeted cost schedule at this particular point. So it shows that this much value of work should have been done actually at this point of time. So this horizontal distance between today and this point, between C and A, actually tells you how many months behind I am. So really speaking, it is the relative placement of curves C and A. If C is below A, it shows that I am behind schedule. If C becomes above A, I am ahead of schedule, right? So you can measure this by this horizontal intercept here. So this is the manner in which we can determine the two most important parameters, namely time overrun and the cost overrun for a project. Now there are some cost schedule control systems, which is essentially these cost schedule control systems criteria, to the three curves that we called A, B and C. They give this name: budgeted cost of work scheduled, which is A; actual cost of work performed is actual cost of work performed, in that manner, and the budgeted cost of work performed is BCWP. And on the basis of these information, what you do is you can define a cost performance index and a schedule performance index. The cost performance index is nothing but the curve C divided by B, as we had seen. So the budgeted cost of work performed divided by the actual cost of work performed, C by B, this ratio can be calculated. Obviously, if the project is performing fine, this will be 1. If the project is performing better than normal, it will be greater than 1. And if it is less than 1, it shows that the project is not performing well. Similarly, the schedule performance index measures the relative placement of curve C with regard to A, and the budgeted cost of work performed divided by the budgeted cost of work scheduled, and this is C by A, and in the same manner this can be computed. What can then be done is the cost performance and the schedule performance indices computed in this manner, because the project manager is interested in both these bits of information together. So it's good to look at both of them together. So what is normally done is you can have a graph which would typically be like this. The cost performance index, 1 is a okay value, 1.5 is very good, and 0.5 is here. Similarly 0.5 and 1.5. What you can do is you can start, for instance, in the month of January, you might have started off on a very good note. So this is the month of January when you reviewed the project. So it shows that both are favorable. What can happen is that in the month of February, when you probably move to the marginal zone, which means that you are still good on the schedule performance index, but on the cost side you have dropped below average, below the normal value. Then in March you might go something like this to an unfavorable situation. Then you might go in April to something like this. Then in May you come here. Then in June you could probably be here. Then in July you could come here. Then in August you could probably be moving here. And then in September you could be moving here. So the point really is that at one go you know that as the project has been progressing, how it has been behaving with regard to the cost performance and the schedule performance. And especially it should not come in this region of unfavorable. Unfavorable region means it is bad on both the schedule front and the cost front. So this is the unfavorable region. You try to remain here, or these are two marginal regions. So this gives you a device by which you can find out exactly how the project is been performing on during different reviews as the project is going on. Now, just to give you an idea of how this review is carried out, we will actually do a review for the project that we had undertaken, and we'll try to compute these values for the three curves A, V and C, and see what is the cost overrun and the time overrun for a particular project. So let's try to do this example of project monitoring, and we will take the same example of the project that we had earlier. Namely, we'll take this very project that we were talking about, for which we had computed the early start and the late start schedules. We'll try to work on this particular project. So of the project considered earlier, suppose that the early start schedule is chosen for implementation. Why this is chosen? Because we are assuming to guard against delays and unforeseen circumstances that may crop up. So although we know that the late start schedule will have a lower NPV, but because of the chaotic conditions prevailing, we would like to use the early start schedule for purposes of implementation. Okay. So the early start schedule then becomes the basic figure which we'll have to be guarding against. Then the budgeted cost and value curve, which is curve A, is simply the cumulative cost curve for the early start schedule computed before, right? So if you look at that particular project, let's see the project. You could see that as far as the early start schedule is concerned, let's look at the early start schedule for this particular project. This is the early start schedule, and we are going to now take this schedule as the plan. We are saying that we are implementing the project as per this plan. And suppose that the project is implemented, and during this process of implementation we take a review at the end of the third month. That means we take a review of this project on the completion of the third month, which is this particular value. At the end of the third month we should have spent 175,000 rupees as per the plan, and these should have been the monthly expenditures in the individual months. Let us see what happens on the site, okay, for this particular project at the end of the third month. So reviewing the project at the end of the third month, we find that the budgeted cost should be 175. Okay, this comes directly from the plan. If you look at the plan, at the end of the third month we should have spent 175,000. So curve A gives us point A, which is 175. So this is a figure that we have picked up directly from the plan directly. The actual money spent we find out from the people who are managing the show, and we find, suppose that we have spent 150,000 rupees. That is the total money. So this has to be found out from the actual site. How much money have you spent on the project? Actually we should have spent 175,000, but we have spent less. Actually we have spent 150,000, let us say. And let us say the value of the work completed. How do we find out that? That is the most important thing. How do we find out the value of work completed? We find that activity 1-2 has been completed. This is the actual status of activities. Activity 2-4 and 2-5 are not even started. This is a field report. And activity 1-3 is 50% complete. This is what we find. And as per plan, activity 1-2 has a cost of 40. And we have said that activity 2-5 and 2-4 have not yet been started, whereas they should have been started by the end of the third. We should have done this much and this much of these. These are not yet. And activity 1-3 is this one, and this is only 50% complete. Out of 2 months worth, it's only 50% complete. So based on this information about the site report for individual activities, we can say that activity 1-2, 40,000 units of work has been done. Nothing has been done here, 25. So in fact, maybe if you expect that some other work has been done, whatever, the total amount of work done should be 40 plus 25, this should be 65, right? So assume that 10 more units of work has been done somewhere, whatever it is. Okay. So the value of work completed is then of the order of 75,000 units. So the way you compute the value of work is simply look up the status of the individual activities and find out how much work has been done and sum it up and take the total. And so we say that this is the value of work completed. So we get the 3 estimates A, B and C which we are interested in. That is all. So you just have to compute A, B and C. Having obtained this information, we then simply compute the time overrun and the cost overrun. In 3 months we find that value of work completed is only 75,000. From the plan, 75,000 units of work should have been done in months 1.67. So we are actually 1.33 months behind at the end of the third month. Okay. And the cost overrun is 150,000 is the cost, 75,000 is the value of work completed, and so there is a 100% increase in cost. So we are on a very bad situation both with regard to the time overrun and the cost overrun. Similarly, the cost performance index and the schedule performance index are just 0.5 and 0.43 respectively, corresponding to these two figures. So you can see really that with this performance, the combined schedule performance index of the graph on this thing actually falls in the unfavorable region at this point, which is very below the is very unfavorable situation, that is both 0.5 and 0.43. So something has to be done to improve the project. So this is how we can get measures of the cost overrun and the time overrun in a project based upon the performance report of the various activities from the site, which tell us what the individual performance of the individual activities is, and then we have taken the actual figures of the money that has been spent, and these are then compared with the original plan, and on that basis we get these figures. This is, mind you, only a monitoring system, right? It tells you that something is wrong. It's like a thermometer which says that something is wrong with the patient. Now you have to actually devise your dose of antibiotics to actually improve the performance of the project. So this monitoring system will then initiate some control action on the part of the managers, and the control actions will probably be in the nature of either reprimanding the people at site or trying to find out what are the genuine problems which have prohibited the project from being done, and trying to make sure that those problems don't repeat in the future. So this is the control action. So monitoring and control of a project is very much linked to the performance at every review of the project. So this kind of a review can be repeated at every time, and this point must gradually improve and hopefully come to the favorable point as you keep on improving the whole project situation. And this movement will be done by suitable medication or suitable control actions that managers will obviously like to take. So PERT cost, as we have seen, becomes a very effective tool for purposes of monitoring the progress of a project, both with regard to the time, the cost and its actual performance. So to summarize, what we can say is that PERT cost provides a valuable framework for project monitoring by identifying the time and cost overruns at any stage of implementation. That is the primary contribution of PERT cost system. Then it uses a cost accounting system based on the project activities rather than on the functional organization of the firm, because all the costing is done with regard to the individual activities, and based on that system we have actually worked out how the expenditure is going to take place. The notion of the work package is central to PERT cost. Neither too big nor too small, well defined responsibility, sufficiently detailed for planning and monitoring, and the possibility of schedules to be chosen for implementation. There is a large possibility of which schedule you choose. It has to be a trade-off between the net present worth, the risk and the convenience that you take, whether you take an early start schedule or a late start schedule or whatever. And finally, project performance, time and cost are the major watchwords in monitoring and control. The project performance, time and cost, these are the major watchwords in planning and control. These can be evaluated and used to compute the time and cost overruns in a project at any stage as we go along, as we have tried to see. And PERT cost, mind you, provides an aggregate measure of how the project is doing. This is, I think, a very interesting point, because a project can contain a large number of activities. Some may be ahead of schedule, some may be behind schedule. You want to find out how is the project performing on the whole. So you are getting here an index of how the project as a whole is performing. So maybe the top management would be interested in this information on how the project is really performing on the whole. So PERT cost can therefore be used as a very effective project monitoring and control tool. Thank you.